Why quantum works differently? In the last video, we ended with a very important question. Why does measuring a qubit change its behavior? The answer was measurement destroys something essential. That something is called superposition. So today, we will understand what superposition really means, why measurement destroys it, and why this makes quantum computing fundamentally different. Superposition. Most people hear this line. A qubit can be 0 or 1 at the same time, and immediately imagine magic. Let's be very clear. Superposition does not mean half 0 and half 1. Two answers at once. Parallel universe, multiple particles. All of this idea was wrong. Superposition is not about many answers. It is about one quantum state. What superposition actually means? Superposition means this. Before measurement, a qubit exists in a state that contains multiple possible outcomes with specific probabilities. Before measurement, the qubit is not 0. The qubit is not 1. It is a combination of possibilities. This is not because we don't know the value. This is because the value does not exist yet. This is the key difference from classical computing. Classical as quantum computing uncertainty. In classical computing, a bit always has a value. Even if hidden, the value exists. In quantum computing, the value does not exist before measurement. Only probabilities exist. Classical uncertainty comes from ignorance. Quantum uncertainty comes from nature. This is why classical intuition fails here. Now we can answer the main question. Why does measurement destroy superposition? Because measurement forces certainty. When you measure a qubit, possibilities collapse. One outcome is selected. Superposition disappears. After measurement, the qubit becomes classical. Quantum behavior ends. This is not a design flaw. This is a rule of quantum mechanics. This explains an important role. Quantum computation happens before measurement. Quantum algorithm create superposition, modify probabilities, suppress wrong outcomes, amplify correct ones, measure only at the end. If you measure too early, superposition is destroyed. The computation fails. Quantum computing is not about observing. It is about controlling states carefully. Superposition is the source of quantum power, but it is also fragile. Why? Because superposition can be destroyed by measurement, noise, environment, small disturbance. Quantum state must be isolated and protected. The more powerful the quantum behavior, the more delicate it comes. The core idea, remember this clearly. Superposition gives quantum computers power. Measurement destroys superposition, and fragility is the price we pay for the power. Quantum computing works differently because information itself behaves differently. Now, very important question remains. If quantum power depends on fragile superposition, how do quantum computers survive at all? Why are they too sensitive? Why does noise matter so much? Why is building quantum computers so difficult? This is exactly what we study next. Thank you so much.